Suppose we have the integral of x times sine of x dx. This integral is an indefinite integral because there are no limits of integration, and integrating this is possible with a technique called integration by parts. There is a formula for integration by parts, and it is the integral of u dv equals u v minus the integral of v du. If the integral is indefinite, like in this case, the final answer should include an integration constant, such as c, which is typically used for the integration constant. So let's keep that in mind. So using this integration by parts formula, I meant to use the pointer. Using this integration by parts formula, we can evaluate this integral. So let's do that. The first step is to identify what u is. I'm just going to tell you right now that the choice of u equals x is a good one for this integral. And the choice of dv equals sine of x dx is a good choice for dv. As you can see, the integrand consists of a u, which we have chosen as x, and a dummy variable, which we have chosen as sine of x dx. And notice that sine of x dx appears here, and the other part of this integrand is x, which is accounted for by this u. So we have essentially made this integrand into this form with these choices of u and dv. So the next step, once we've found what u and dv need to be, which is often the most difficult part because it's not always obvious, is the next part is to identify what v is and what du is. So let's do du first. How do we do that? Well, we can take the derivative of u and say du with respect to dx is, well, what's the derivative of x? That's 1. And for this technique, it's acceptable to multiply the left-hand side and the right-hand side by dx to get du equals dx. So I took this dx and I multiplied by dx on the left and dx on the right, which is not a mathematically rigorous operation, but it's all right for the technique of integration by parts. Next, we need to go from dv to v. The way I like to do that is to divide both sides by dx. So let's do that. dv dx equals sine of x. In other words, we have the derivative of v equals sine of x. So what v would yield sine of x when differentiated? Well, the derivative of cosine is negative sine, so The derivative of negative cosine is sine. In other words, if we choose, or we don't really have a choice here, if we use v equals negative cosine of x, then when we take the derivative, we get sine of x back. I could have added a constant here, but I'm not going to do that. The constant could be considered 0 if you like to think about the generalized antiderivative. All right, so we're working on an indefinite integral, so the next step is to rewrite this integral in terms of, well, rewrite this integral with this form. We have this form currently, we want this form. So the way we get this form is by substituting these quantities that we've defined, u, v, dv, and du. So let's do that. So u is x because of this. V is negative cosine of x. So let's make a negative sign out front and put a cosine of x. Don't forget this negative sign here, it's not a plus sign. The integral of v, what is v? Negative cosine of x. Cosine of x, now I'm going to use that negative sign to make this a plus sign. And finally we have du, which is just dx. So that's an easy substitution. All right, so we have now rewritten the original integral using the integration by parts formula, so hopefully this integral here is easy to evaluate. Now, the derivative of sine is cosine, so the antiderivative of cosine is sine, so we can evaluate this integral. Let's go ahead and do that. I'm going to move this down. We don't really need those equations anymore, as we've used them, and so let's rewrite. We have negative x cosine of x, and this integral, which is an indefinite integral, evaluates to sine of x, and don't forget the integration constant because it's an indefinite integral. So in a sense, this integration constant here is for this particular integral, and also this was expected because the original integral was an indefinite integral. So technically I could have added the plus c at this initial step here in anticipation of the integration constant, but it's, as long as the plus c is in your final answer, you are good. And I think this is the final answer. I don't think it can be simplified anymore. So there you go. This is the first example of integration by parts that I've done on this YouTube channel. And let me know in the comments if you'd like me to do another example of integration by parts.